So when we shift the hyperbola, we get the generic form of the equation, this with the h and the k. It's been very similar to everything else we've been working on. This shouldn't come as any surprise to what it looks like. What happens now, same thing as it was last week, the value of A is still the center to your vertex. The center to vertex. B is the center to the co-vertex. C is the center to the focus. Okay. When you're with the hyperbola, since it's subtraction between the two, to find the value of C, C squared is A squared plus B squared. And remember the little app button on your calculator will help you to distinguish the direction when you're moving stuff back and forth.
Wait, on hyperbola, it doesn't matter where the A and the B squared go.
No, it doesn't matter on the A for the hyperbolas. It's which comes first, x squared or y squared. Okay. The x squared or y squared comes first. That's how you're able to distinguish between the two.
And this one isn't basically just the one that right first.
What's that?
Isn't it like basically just the one that right first?
Yeah, whichever one comes first. That's it. That's really all it is. What'll happen with it though is that in the hyperbola sometimes they like to hide the negative. They might put the negative x squared or the y squared value first, but that means it's supposed to be the second term. A lot of times when people will screw up here is notice how the y squared term comes first. You'll flip-flop your h and k. Similar to how you guys screwed up with the h and k's when the y squared came first on the ellipses. Same idea. Just be careful as you're reading them through. Okay? Remember, x squared comes first, goes left and right. Y squared comes first, goes up and down. And then obviously we will have, one other thing we will write out with the hyperbolas is we are going to write the equation of the asymptotes, those slant asymptotes. We will do that as well. Last week when we did that, you had your ordered pair, your y-intercept was always 0. So all you do is figure out the slope. This time we're going to have, not at the origin, our ordered pairs we're working with is the the coordinates of the box, remember the little rectangular box we walked out with our slope,
Yeah.
as well as the point of your h and k. So just a little bit more algebra thrown in there. Shouldn't be anything super crazy. So let's have some fun. It's one of these. I forget which one it was. I guess I can delete these out. You know what? Let's do the other one first. Let's graph the translated hyperbola. We have y plus 1 quantity squared minus x plus 1 quantity squared over 4 equals 1. Excuse me. Now, this just tells you what direction is it going?
Up and down.
Up and down, because what came first?
Why?
Y. What's the value of a squared? 1. Very good. So you'll see this from time to time. It may not have something thrown underneath it, so if you want to put something underneath there to help you out, by all means, go for it. Where is your center going to be at? Where's your h and k?
-1, -1.
Well, -1 and -1. It's a good thing they're both -1, so even if you did screw up your h and k, you screwed up and you were still okay.
So H comes first.
H always comes first, yes. Because what comes first in the alphabet?
H.
Very good. What comes first in the alphabet, X or Y?
Y. No, X.
It's like why then don't.
You just turned a little shade of red there, but that's okay. So, so a squared is 1, b squared is 4. What's c squared going to be? 5. So a is going to be plus or minus 1, b plus or minus 2, and c is plus or minus root 5. Notice how it's the exact same setup as we did before. Shouldn't be horribly scary. And we just start this one at -1, -1. There's my center. That A value, remember, the A value is going to be the distance from your center to your vertex. Since our vertex, our hyperbolas are going up and down, my vertex needs to go up and down. So I go up 1, and I go down 1. Like we did yesterday or last week, we always want to make a running tally of what we're doing. Label everything. We have a vertex, so this was our center. Our vertex is going to be at -1, 0, and -1, -2. Notice all we had to do was just add 1 to both y-coordinates because we went up and down. Easy. Now I'm going to add to both the x-coordinates the b value for my co-vertex. 1, 2. 2. So the co-vertex is at -3, -1, and +1, -1. You okay with that? Make your rectangular box now. Through that rectangular box, the diagonals create your
Asymptotes.
asymptotes.
I still don't know how to say it.
All right. Slant asymptotes, those, excuse me. We'll come back to the slopes of that here in 1 second. I want to put in the foci while we're thinking about it. Foci, I have to go, remember, since it's going up and down, the foci are going to go up and down. So that means the x-coordinate doesn't change, but I'm going to add and subtract √5 to my y-coordinate. So when I write out my foci, move this up so you can see, when I write out my foci, the x-coordinate didn't change because it's vertical, so it's -1. But I'm going to add, oops, √5, and I'm going to subtract √5 to both of them. Okay? Yeah. Square root of 5 is a little bit more than the square root of 4, so it's a little bit further away than 2. Just walk off 2 more spots from your vertex. And just pop it in. Okay? Now the best part of the whole thing, the curve. Hug your asymptote. Go through the vertex and hug your other asymptote. It sounds so dumb, doesn't it? But it's great. I didn't do a good job of hugging the asymptote.
Is there like a short version of that?
Bless you.
To say asymptote every time you say it?
What's that?
Is there like a short version of that?
An asymptote?
Yeah.
You just said long on that one.
Tote.
Like,
It's gotta go to the tote.
like
But it sounds cooler if you gotta say asymptote. It sounds like you.
Yeah, but like when we're writing it, I don't even know how to spell it. So.
Like, is there like an abbreviation?
ASMY.
ASMY. Okay.
Last bit now. Last bit as we go through this is we're going to write out the equation of the lines that created the asymptotes. So go back into the vertex. Our center, excuse me. Our center was located at -1, -1. That's one of my ordered pairs. Well, to get the slope here is going to be pretty easy. I'm going to go up. What did we do? We went up 2. Oh, sorry. Up 1, and we went right 2.
Yeah.
Or we go up 1, left 2. So our slopes is +2 or -2.
Wait,
Yeah,
what?
1/2.
Is it 1/2?
Did I say 1? Yeah, I meant. Yes, up 1/2. Sorry about that. I'm sorry. And what point am I going to use to write the equation then? Big point slope form. We have the center is our point, and that's our slope. So we're going to use the equation with -1, -1.
Okay.
So I'm going to use y minus y sub 1 is my slope, x minus x sub 1. Good old-fashioned point slope form. This just takes an extra minute than what it did last week. 'Cause last week all you do is just throw your slopes in because your intercept was 0.
What's the point of the asymptote thing?
That way you know how far out the curve is going to go. By putting in that little rectangular box, it creates the diagonal. The diagonals are what the curves are going to always be approaching. And it shows you how it's going to run off. Okay. So filling in the blanks on this one, we get y plus 1 is 1/2 x plus 1. Distributing, subtracting 1, you should get one equation being y equals 1/2 x minus 1/2. And if I use a negative slope, I believe we get y equals negative 1/2 minus 3/2. Those should be my two equations if I substitute and solve out.
Is there X?
Did I forget to put the x? Yes, I said it, but I didn't put it down. Right? Katrina, welcome. You're probably like, oh, crap. Nervous chuckle. Okay? It looks like a lot, but the math isn't bad. No, you're using the same center, you're still using the same point, because
Exactly. What's your over this house? That's what you told me.
and sometimes you might want to write that out. I just, Duke says we're multiplying to a 1/2 to a 1. I knew that it's going to be a negative 1. I just subtracted 1. It was quick to do in my head, that's all. Otherwise, I would just written it all the way out. Because you get negative, because you distribute the negative, you get negative 1/2 x minus 1/2. Then you subtract the 1, so you get minus 3.
I don't like it, but this is better.
All right. Let's go the other direction.
Great.
Let's go the other direction with a shifted hyperbola. Let's write the equation given shifted stuff. So if I have a hyperbola that has the following information, we have a foci at 5,2 and 5, -6, and I have vertices at 5, 0 and 5, -4. You could probably tell right away what direction this is moving. Which way is it going?
Left and right.
I don't know what I'm doing either.
It's up and down.
Oh, yeah, because.
All the x values, remember guys, if the x values for the vertex and the foci are the same, that means it's vertical. Okay? So when we did this before, we're going to do the same idea. We're going to get a rough sketch of what it looks like. Vertices here. So it's got to do that. Your vertex always looks at the focus. So we know it's got to be a y² hyperbola. So I know it's got to fit in the form y minus k quantity squared over a squared. Oops. Not equals minus x minus h quantity squared over b squared is 1. Okay. We need to figure out our h and k. What's going to happen halfway between the vertex, the two vertices? What's going to happen halfway between the foci? What's going to happen halfway between the co-vertices if you had that? The center. Now, we know for certain that the center, the h and the k, is going to be at 5 comma something, because it's all vertical. So if I'm at 0 and 4, or excuse me, -4, what's 0 plus -4? -4. What's half of it? -2. So that means my center is located at 5, -2. So there's my h and k. How to get that? Remember, it's going to be the midpoint of a vertex, it's the midpoint of a focus, it's the midpoint of a co-vertex. The center, it will always, always, always be the midpoint. Okay? The x coordinate's pretty, since it's vertical, they're all going to share that same x coordinate. Whereas if it was horizontal, they all share the, correct. So now, how far away is negative 2 to 0? 2. So what's your value of a? 2. So what's a squared?
4.
Okay. So I know that a is 2, so therefore a squared is 4. All we're doing when we get to a value is distance from center to vertex. Well, center to the vertex is 2 spots.
Crap.
Okay. I don't have b, but I have c, center to the focus. How far is negative 2 to positive 2? 4. So my c value is 4, therefore c squared is 16. Well, c squared is a squared plus b squared. So 16 is 4 plus what?
12.
12. Now it's just a matter of substituting in. Don't get fooled by the y squared term going first. You guys will have a tendency of writing y minus 5 here because you think HGK is going to go first as the first term. It's flipped here, okay? So you wind up with y plus 2 quantity squared over 4 minus x minus 5 quantity squared over 12 is 1.
Nice.
When you're writing equations like this, you don't have to worry about finding the slant asymptotes or any of that kind of stuff. You don't have to worry about that.
I like it better.
What if it asks what it is?
What's that?
What if it asks like what it's like?
Oh, then you can go ahead and get, bless you. Then you can, you know that you've got your b value. You know, you can walk that out, and you can figure out your slope to get in the corners. This one probably a little bit trickier to find the slopes of it because of the fact that your b value isn't clean. Because you got that root 12 there, you'd have to move out. So your slopes would have a root in it. I'm mean, but I'm not that mean. You knew it was going to happen. You knew it. So let's go through the whole rigmarole with the whole, figure out what the conic is, find all the parts, graph it, and go have a good old time. So we have negative 9x squared plus 16y squared plus 54x plus 64y minus 161. For lack of better terms,
I'll say it.
it kind of does after a while. But guess what you're going to have to do? Complete the square again. Boy, I hope we've gotten good at that by now.
Oh yeah.
One of the things you probably can also tell right away.
You gotta get a -9.
Well, I don't want to take the negative and 9 out. I'm going to move things around because, remember, in a hyperbola, you've got a subtraction between the two. So let's move stuff around here. Let's put the y squareds first this time.
Are you serious?
What?
Watch.
I already put the X's first.
Yeah, X's go first.
Why are we doing this? Do we have to?
Think about what it is there. When you have a negative value,
Oh, God.
the reason why I'm taking that negative value and putting it in second is because in a hyperbola, you have subtraction. So I can factor out the negative and turn it into a subtraction problem. Okay? You don't have to do it that way. You could rearrange it later.
I just
But anytime you see that you have a negative x squared, a negative y squared or something, more often than not, you're going to be able to, you know that you're going to have a hyperbola because the hyperbola is the only conic with subtraction in it. Everything else is always addition. Okay? So when we get this far, now I have to worry about my leading coefficients. So I'm going to factor out the 16. We have y squared plus, what was that, 4y plus blank. Take out the negative 9. I get x squared minus 6x plus blank. And now I have to put back in 161 plus 16 times something minus 9 times something. Since I took out the negative, I gotta take it out on the other, I gotta put it back in on the other side as well. What's half of 4?
2,
Squared.
4.
Okay. So we get 16 y plus 2 quantity squared. I had to add 4 to both sides. Minus 9. Half of negative 6? Negative 3. Square the negative 3 and you get 9. And now you have 161 plus 64 minus 81. 144, isn't it?
You say so.
If you divide everything up by the 144, I do believe you wind up with some clean a squareds and b squareds.
Yeah, hold on a second.
I'm holding, sorry. I didn't mean to get too far ahead of you. It's 9 and 16, right?
Yeah.
Thought so. Like I said, a lot of times you're going to get these perfect squares that go back and forth, 9, 16, 25s. You know, you kind of have the same numbers over and over again. Now you can finally go ahead and graph. Well, you got to find all the other parts for it.
I don't want to
If
do
I can
that.
find room
I
on
got
my
this.
paper.
Well,
Calculator.
Can I grab
Can
it?
it's in the calculator? Yeah. F. Like can we? Conics.
No, you can't.
Yeah.
No.
Don't believe it.
Okay.
what's your H and K?
That's
3 and negative 2.
Good, good. I was waiting to see if anybody got that flipped.
I'm too smart.
SMLT.
I got it.
It's 3 negative 2 because this is a y squared hyperbola, which means it's going to go
Up and down.
Up and
up
down.
and down. Good. You know, this has to go up and down. Our a squared value
Dotted box.
is 9. B squared is 16. C squared, therefore, would be 25. Ooh, nice. Yay, we get really easy numbers. Okay? Yeah, but you have to remember, I'm not going to let you use that on Friday. Oh, that's right, we're going to have a test on this stuff on Friday.
Yeah. We're not going to tell us this
I'm
now.
going to murder someone.
This is not the easiest week already.
Why aren't you here on Friday?
Oh, you should move it then.
All the freshmen.
Yeah, you should move it.
Yeah.
We've got a lot of freshmen, you should move it.
You got.
This works out pretty easy to plot as you go through it.
Kill you.
Here's our center. Our value of A is 3, so we're going to go up and down 3. 1, 2, 3. So we have vertices then. At 3, negative 5, 3, 1. Co-vertices, bless you. Co-vertices, we have to go left and right 4. 1, 2, 3, 4. 1, 2, 3, 4. So that will be at negative 1, negative 2. And 7, negative 2. Everybody all right with that? Now what am I going to do?
Draw the box.
Draw the box. What's in the box?
I know.
When would you get this negative 7?
I was adding and subtracting because the b value is 4. So all I have to do is shift it left and right, 4. So all I did was just add and subtract 4 to my x coordinate of my center.
Okay.
Okay. Diagonals for your asymptotes. Our slope, well, let's see here. We went up 3 and we went over 4. 3/4.
Yeah.
Oh, got to get our foci first. It's nice when you have an easy value where you can just walk 5. What's that?
3, 3.
Yeah, 3. Yeah, 3, 3.
And 3, -7.
Yep. You're just going vertical, so we're just adding to our y values of the center. So add 5 to this, subtract 5 to that. That's where we get the 3, 3, 3, -7. So here's 5, 6, 7, 2, 3. Just feel like being a little bit crazy. Last, yes, ma'am.
Is the curve like supposed to actually cross over and touch the
It never does touch the asymptote. It approaches it.
Never gets close.
How close
It's-
does it get?
You just, what's that?
How close does it get?
As close as it infinitely can get.
Huh?
You can always get closer to something without getting to it, because you can always take half of something.
Until you get to the bad.
So you get, well, no, because you can still take half of it. Anyway, it doesn't technically touch it. It's the where it's a curve is followed.
Mine never touches that thing.
I won't yell it if you accidentally draw and it touches the asymptote. Oh no, black hole. It's not a big deal. Last part, we're going to write the equation of the line. There's my slopes. What point am I going to use?
3 negative.
The center, very good. I'm going to use 3, -2. So one of them will be y plus 2 equals 3/4 x minus 3. Y plus 2 equals -3/4.
Why is it y plus 2?
There's two.
My slope form,
it's
so y minus a -2.
Oh, I thought it was y back.
So if I solve those out, so you get y plus 2 3/4 minus x minus 9/4. Subtract the 2 over, you get 3/4 x minus 17/4
What?
for one of them.
Yes.
Subtracting 2 is the same thing as subtracting 8 over 4. -9 minus 8 is -17. There's one of them. The other one will be y plus 2, -3/4 x plus 9/4. And now when I subtract over the 2, I'm subtracting over
There's 2 strong.
8 over 4, which is 1/4.
It's 1 page already.
And those are your 2 equations. Yes, sir.
So we have found those for every
Yes, sir. If it asks you to, obviously. Okay. But more often than not, you will. Yes, ma'am. I don't know yet. Probably not. If anything, I'd give you the dumb calculators. So you can still know how to add or subtract a fraction. You can't do it in your head. Yes.
Would it be plus 1/4 on the last one?
Yes. Thank you. Thank you. Yeah, I had it in my head. I'm subtracting the 8. Yes, you're right. So it's plus 1/4. Sorry about that.
We're not trying to.
I don't know. We'll worry about that as it gets closer. Okay. How many of you guys aren't here on Friday?
Don't worry.
Everyone.
Don't worry. I won't be here. I'll finish.
I'd rather have
That makes sense.
No, can't. We have too much stuff going on next week.
We had those circles too.
Oh yeah, it's all of it.
Uh,
Oh, yeah.
I gotta remember those.
I'm dropping out.
Yes.
Tonight, man, what's this stuff? I'm just
I gotta memorize the circle.
I gotta re-practice everything.
Are we gonna get a study guide?
I don't know.
Please.
It's all right here. It's everything. It's all this. You gotta know how to do this. I can't remember which one.
I'm about to jump out the window. I just want to be. I'm
Going straight.
Fuck it. It's my deal.
All right, let's see. Let's try this.
You should give us
I don't want to be
classified
anything else. I
accounts.
want to graduate and be just sit at home and do nothing. And then
Same deal.
Not another one.
Let's try the same one.
That's gonna take us like 15 minutes.
The next one has to go
We'll literally
first.
paper.
Nice.
I'll just have Lucy do it.
Another quick little one here to set it up.
It's pretty quick.
He did it on purpose. He's joking. I need to find these. Yeah, so I think it's one.
9x squared minus y squared plus 54x plus 10y plus 55.
I want to watch you. We gotta set the Y first. How about I set this one up?
Do I have to put the y squared first on this one?
No.
Why not?
why not?
Well,
Put the x squared first.
what's the coefficient of the y squared?
What?
It's negative. So you want to put that one as the second set. So here, you had 9x squared, 54x, minus y
What
squared,
if I did the other one?
plus 10y. We'll set that equal to negative 55.
Okay.
Whenever you see a subtraction, put it as the second term.
All right.
Because hyperbolas are the only ones with subtraction between the two. The other ones, it doesn't matter. Okay? Because the other ones with the ellipses, that's when the a squareds are the ones that move around, because that's where the values are larger. Hyperbolas is just what comes first. Now the reason why I wanted to show you this one is the trick that happens with the y squared trick. Obviously here I got to factor out the 9. I get x squared plus 6x plus blank. What do I take out of the other one? Negative 1. Dang it. And now I get y squared minus 10y plus blank. On the other side I have negative 55 plus 9 times something minus 1 times something. A lot of times what people tend to forget is when you have that just a negative coefficient of 1. You forget to pull this stuff out. Okay? That's why I wanted to spend a minute on this one here.
It's got fractions and fractions.
I know.
Oh, I hate this one.
Half of 6 is 3. So we have 9 x plus 3 squared. Add 9 to both sides. Half of negative 10 is negative 5. Square it, we're going to add 25. Okay. So we have negative 55 minus 25, I believe, is 80. Negative 80. Negative 80 plus 81 is? 1.
Nice.
Why?
Divided by like something because it's 9 and negative 1. So it's not sweet.
Now, you've already got the side equal to 1. What are you going to do here?
Divide by 9.
can't, because it just kind of puts you in an infinite loop if you go that way.
And multiply by 1/9.
No solution.
Ah, no solution. Doesn't work that easy. What happens now, and this is where this is kind of where you guys left off. You had a question on like 37 and 39 over the weekend. What happens here is you want to start multiplying by kind of like a conjugate, if you will. If you start to get fancy on this one, I believe you wind up with 1/9 over 1/9.
I knew it.
Okay? The reason that is, the reason that one works like that is because what's 1/9 divided by 1/9?
One.
So what you wind up doing here, oops, you're multiplying everything by 1/9 over 1/9.
This is poo-poo.
Okay. I don't know. I haven't written it yet.
Wait, where'd you get the 1/9?
It's because
1/9. It's kind of the conjugate of that first term there. Okay. That's the weird spot where you wind up having to multiply out by that little bit of a conjugate there. Okay. Yes, sir. Yes, sir. Okay.
What was the definition?
What happens if there's like, say, there's like 9 and then 4? You know what I mean? Will that actually?
It does, but it just works out to be another fraction.
Wait, is the 1/9
So-
also just the 9, or is it because that other one is negative 1?
What happens now? What happens now is that as you distribute through, I want you to see what happens.
Oh, yeah,
We're done with
that.
Taking this value here, you get 1/9 over 1/9 times the 9 parentheses squared stuff. Okay?
Remember when you said this was going to be a quick one, Calvin?
What I'm trying to show you here is that this is how this fraction is getting rid of the leading term coefficient. When I multiply this times the -1, I'm just taking basically 1 times -1. Am I changing that value?
No.
No. Am I changing the last value? No. And this was your concern about what happens with the other fractions. Well, you won't see it as often. But what's 1/9 times 9? 1. So you wind up with, was it x plus 5? Or x plus 3? But when you're dividing by a fraction, we can do it like this. I don't want to mess with you guys too much.
Oh.
Worst for your math problem.
We just not.
No, I don't want to get. I don't want to
Promise me we won't have to graph any of
It's
this.
already too late. I don't know what's happening.
It doesn't matter if you graph it. Honestly, think about it. If you think about the graph on that one, all you're doing is just adding a third, subtracting a third.
The graph
You know what I
is just
mean?
make
Your
it
a value, because your a value, a squared is 1/9. There means a is just 1/3. What would the tough part be is when you start worrying about your asymptotes. What I'm looking at here is just going into the standard form. Okay? Yes, ma'am. Right, because when I multiplied it out, 1/9 over 1/9 is still 1. This kind of follows the same idea of rationalizing out your square roots. When you had 1 over root 3, you just multiply top and bottom by root 3.
Wasn't it be negative 3?
You got root 3 over 3, okay? It also worked with the idea of 2 over 1 minus root 3. You'd multiply top and bottom by 1 plus root 3, okay? You're using the idea of the conjugate. You're just shifting it.
We need the 1 from the y.
No, you don't have to. It's just there just to remind you that it's just a negative 1. Okay? So I only have, these are the shifted ones, I believe. Yes, ma'am.
It's like 1, 2, 3, 4, 5 problems. So it's like, oh, well, 5 problems.
But there could be a
Four
weirdness, and I don't remember if I gave you one of these
Yeah,
or
you
not,
know.
double checking it right now.
Is this 10.6?
This is still 10-6, yes. This is the shifted stuff. So let's see, 19 and 20 to write the equation. That's pretty simple.
Nice.
53, 57, that is classifying graphs. So 53, 57, and 62. I don't think they have them, but for these three, make sure you do all of it.
Even the asymptotes?
Yeah.
Okay.
Okay. So it's really, yes, I know you guys are like, oh my goodness, it's so hard to read all this stuff out. It's so
The
I
acetone
don't think you get 3 of them.
Only 3. The acetone is done. I don't even use it. 3 pages of my whole thing is done.
And we'll go from there.
Equation that you don't really write. I'm angry.
What?
Go home.